Welcome to our next video in our Big Ideas, lesson 3.3, page 120 for our 8 general students, and lesson 12.3, page 544 for the 7th accelerated students. Ladies and gentlemen, I appreciate you coming tonight and today with your best attitude and effort, doing everything you can to become a person of character and intelligence. Today, ladies and gentlemen, tonight we are going to apply what we learned to find the sum of the interior and exterior angle measures of a polygon. Our essential question: how can you find the sum of the interior and exterior angles of a polygon? Now, I know, those of you who are developing into persons of intelligence and character, you've already done what you know you're supposed to do before you watch these videos. You've taken your own notes because you understand the value of doing that and the learning process, in that, hey, now you have an idea in your head, you've read it a little bit, you've written down your own notes and your own words, and now we are going to discuss it together as another opportunity to learn and understand. Ladies and gentlemen, as always, when you are taking notes, if it's helpful for you, watch, listen, and then stop the video, and then write everything down before you put the pencil down and continue with the video. Ladies and gentlemen, you will notice the book has convex and then concave notes, and I am going to talk to you about them in reverse. We're going to talk about the concave figure first. The concave figure where if you read the definition and wrote it down, it says, hey, I can draw a line segment from one vertex to another. From any two vertexes in the figure, if that line segment lies completely outside of the polygon, then I have what we have as a concave figure. And it almost looks like this indentation is a cave, right? Because caves go inside mountains. That's a concave. We're not going to deal a whole lot with concave because that's just not what we are asked to do at this level of math right now. Are you going to later? Absolutely. And you're going to learn all the things that we're discussing about how to do these things with a concave figure later. We are only considering learning about what we call convex. Now, convex says I can draw that same line segment between any two vertices, and that line segment will lie completely inside the figure. So from that one to that one, completely inside. And if you're asking, well, what if I do it from this one here to that one over there? It's right on the edge. Well, on the edge is still inside. It's still inside. There's nothing on the outside of that figure, and that is convex. And that's what we're going to be dealing with this year. Ladies and gentlemen, you also took some notes from the top of page 544. Again, it's 120 if you are with the 8 general class, page 120. And where we talked about polygons. And again, polygons are very important to know. Three or more line segments. I think I actually wrote this down. Yeah, polygons, closed plane figures made up of 3 or more line segments which only intersect at their endpoints. Only intersect at their endpoints. So, when I come over here and look at these examples of what we call polygons, we can plainly see that these line segments intersect only at their endpoints. There's at least 3 line segments, and the figure is closed. There's no opening. Okay, all 3 of these examples are polygons. And when we come over here, well, we can see this first one. That's not a line segment. It's rounded. This one's oval. That's not a line segment. I do have students, though, who do question me, so I'm going to talk about it right now. This particular figure right here, Mr. Ross, it's made up of 3 or more line segments. All those line segments are connecting at their endpoints, except 2. Ladies and gentlemen, if you look right in here, to take this figure as a whole, it is not a polygon, because those intersect at their midpoints. I could take individually the top and say that this triangle is a polygon and the bottom one is a polygon, but as a figure altogether, one shape, it is not a polygon. All right? Because they don't all intersect at their endpoints. All right, so ladies and gentlemen, let's do a real quick review of concave and convex. Let's come back over to these polygons, which are polygons, all 3 of these. Which ones are concave and which ones are convex? Well, outstanding. If you said that this triangle was convex, you are correct. It is the convex, and the other ones, the other 2, both of these are concave, Again, we're not going to deal a lot with concave because you will learn about that later. We're just trying to understand the easier one, the convex, this year. Ladies and gentlemen, our task today is to find the sum of the interior and exterior angle measures. This first video, we're going to concentrate on the interior angle measures, and you took down a formula from the book more than likely. And your formula is going to look a tiny bit different than mine. Mine says that the sum of the interior angles is equal to 180 times the number of sides minus 2. From the book likes to reverse that. They go n minus 2 times 180. And you know what? The commutative property says we can multiply in any order, right? So I prefer to do this. The book prefers to do that. You get to do what you prefer to do, all right? So we take the number of sides of the polygon, subtract 2, and multiply by 180, and we will get the sum of the interior angles. And as quick proof, we know a triangle. We already know it. We have it memorized. A triangle is 180, correct? So if you take 180 times 3 minus 2, because there's 3 sides to a triangle, that's 180 times 1, which equals 180. It always works. You know it does, because I've proven it to you before. Ladies and gentlemen, let's move right along. And let's do what we said we were going to do in this first video. Find the sum of the interior angle measures. And we're going to do it for this particular polygon. So ladies and gentlemen, we know if we're going to find it, we know that we're going to use this formula that we're asked to understand, 180 times n minus 2. And so the first thing we got to do is, because we want to know what the sum is we've got to count the number of sides. So I always mark them as I'm counting, because otherwise I might count one more than once. So 1, 2, 3, 4, 5, 6. Okay, so now I can rewrite this as 180 times 6 minus 2. That's 180 times 4, and that is equal to 720 degrees. Now, ladies and gentlemen, while I'm here, I want to discuss something that's another way that you can do this that will show you why this formula does in fact work. So I'm going to come over back to the figure, and I'm going to show you. We already know that a triangle has a sum of the interior angle measures of 180 degrees. And you need to know that every single polygon that exists can be divided up into some number of triangles. So let's take this particular figure right here, the 6-sided hexagon, and I'm going to start with this vertex right here. And I'm going to make a triangle by drawing a line segment to that one. So there is a triangle. And then I'm going to draw from that same vertex all the way down to that vertex, and there's a second triangle. And I'm going to draw from the first one all the way down to that vertex. That's 3, and over here is 4. So we have 4 triangles that we made inside that hexagon. Where does that 4 come up? That 4 comes up right here. So the reason we go n minus 2 is because that is the number of triangles that are inside there. And if you went 180 plus 180 plus 180 plus 180, of course you would get 720. So you can always divide a figure up into triangles and use that to find the sum of the interior angle measures. Let's do it one more time, where it says the sum of the interior angle measures for a 9-sided polygon. Well, we don't see it, but we know it's 9-sided, so we use that sum is equal to 180 times n minus 2, which is 180 times 9 minus 2, which is 180 times 7, and 180 times 7 is equal to 1,260 degrees. Well, that's pretty straightforward. Now let's use that to help us find an angle on the inside of that polygon. It says find the value of x. So I'm looking, here's x. Well, the first thing I need to know, is what is the sum of all of them? Because if I know what the sum of all of them is, then I can use that to help me find the value of x. So again, I'm going to count, and I've got 1, 2, 3, 4, 5, 6, 7 sides on this one. So s is equal to 180 times n minus 2. That's 180 times 7 minus 2, which is 180 times 5. And 180 times 5 is equal to 900. All right, so now I know that the sum is 900. I also know that if I have all these triangles, I can take that one I don't know, and I can add it to all of these. So I'm going to add all these up. Now I can write them all out. I can go plus 130, plus 128, plus 125, and make a big, huge honking one that I have to simplify. Or right now, I'm just going to do it to shorten this video. I'm going to simplify by adding them all together and tell you that that is equal to 776 degrees. And we know that when we add all those angles together, it's got to equal 900. We found that out in the first step. So now all we have to do is subtract 776, and we get the fact that that angle that we didn't know, we now do know as 124 degrees. One more time, find the value of x. So the first thing we're going to do is we're going to find the sum of all of the angles. So s equals 180 times n minus 2. And we're going to count them up. 1, 2, 3, 4, 5 sides. So 180, times 5 minus 2. That's 180 times 3. We multiply that together, we get 540 degrees. So now we know if we add all those angles, we're going to get 540 degrees. Well, let's go like this. I'm looking, and these are the two angles we don't know, right here. Both of them are valued at 2x. If I add that together, I have 4x's all together. And then I'm going to simplify by adding the other 3 together, and when I add the other 3 together, I get 400. And when we count and add all that together, we know the total sum is 540. So, using all those skills that we learned way back, isolating the variable using inverse operations, doing the same thing to both sides, using properties of equality to find out that the value of x is in fact 35 degrees. Now that's only the value of x, and that's what they asked us to find, so that's what we do know. But just understand, if they ask us a different question, if they said, hey, what is the angle measure? They want to know what that angle actually measures, because we have two x's. What are we going to do? That's right, 2 times 35, and say that that angle is 70 degrees. Outstanding. Ladies and gentlemen, we've reached our first quick write of the night. Our quick write on finding the value of x. If you would please make a very rough drawing and label all the angles, and then go through the steps that you need to find that missing angle measure. When you're done, take a quick break so you can come back refreshed for our second video of the night. I'll see you in a few moments.